Okay, hello everybody, welcome. This is week 5 of our CAD level 2 class. So hopefully you all, seems like you don't have any questions up till now, so you're able to model the most recent piece, which is the piston of our air engine project. Again, I guess no one new has joined, but last call, if you have any questions about any of the parts that we've modeled so far. For homework, you guys have done the base and the piston. And in class together last week, we went over the cylinder, which you might recall, our kind of square prism shaped cylinder. So we're starting to make some progress here. Confused on how to make the piston. Okay. Any specific part of the piston that you have a question about, or like part of the drawing, or? Bottom part, okay. Yeah, so you have a general idea of what this thing looks like, right? Based on the drawing. So this drawing may be a bit trickier than the ones that we've looked at in the past, partly because there's not as much in it, right? Sometimes the less you have to look at, less you have to work with, the harder things can be. But hopefully from this drawing, you got the idea that this is supposed to be two cylinders basically stacked on top of each other. One kind of long rod-shaped cylinder and one like stubbier, thicker cylinder. So if you got that idea, then the execution is hopefully not too bad. But the idea is you can just extrude two cylinders, one right above the other. So I guess I can just do a quick demo. When you say the bottom part, are you referring to, I guess, this hole here, or the larger structure, the big body? Okay, so you're okay with the hole that goes through the side, right? Yeah, this drawing, like when you look at it, it might be pretty confusing, but when you look at this view, all that's really happening is we're kind of looking at it from, you see where my mouse is pointing. If your eye was like right there and you were looking into this view, this is what you would see. So there's like a solid small circle, there's a bigger solid circle, and those are just the two rods that you're looking at. And then this dashed line that goes through it, that represents this hole. So it shows that this little hole is a through hole. So yeah, let's just go through it. So the big stubbier part of it, that's this diameter. You can see it's about ½ inch. It's 0.4994, but you'll recall when we made the cylinder that the cylinder's diameter was like 0.5001. So in real life, you'd want like the piston to be just a little bit smaller than the bore of the cylinder, so that they can slide in and out really easily. So we don't care too much about that. I'll just make it a 0.5. And if you're just joining us, we're just going over the piston, which was the homework from last week. So I guess now we'll have a recording of how to do it. And if you want to compare how you did it versus how I did it, or something like that. Anyway, the thick part of the piston diameter is 0.5 and the depth is 0.49. So I'll just do that. And then for the thin part of the cylinder, I can just make another sketch on one of the circular faces. And I'll just make another circle. And the diameter of that will be 0.313 for this dimension. So what do we have here? And I'll extrude that. And the length of this part, I can see is, I have to do a little bit of math. The overall length needs to be 1.813, and the part that I already made is 0.49. So I can just type in actually I can just type in like that mathematical expression, the difference between those two numbers, and it'll just calculate it for me. So this is how I make like the body part. Does that answer the question you had? Hopefully you can see now, perhaps it's not as complicated as it might initially appear. Yeah, and then the last part to finish this off, the only feature I didn't show is this hole, but hopefully by now you have an idea. You can use their, actually the hole tool might pose a bit of a problem because you don't have like a flat surface to do it on, but you can just use an extrude cut if it doesn't work. So like I can just make a sketch on one of these planes. And I'll just use the technique that we know and love, which is drawing a circle, goes up to 1.625. And the diameter is, we'll just call it 1.144. And then I would extrude cut through all. And this is basically it. This is what the final part looks like. So you can see this bottom view. I know it's not the most clear thing in the world, but hopefully comparing these side by side, you can imagine like this is the big circle, solid line. This is a little circle, it's a solid line. And then the thing that we can't see, this hole, becomes that dashed pair of lines that kind of goes straight through. So there you go. All right. So that takes care of that. And this week for our first part of the class where I talk about things, today's subject kind of is an extension or a continuation of what we talked about last week, which was importing parts like into your Onshape, right? Like, so the idea was you're working on this big project and not all the things that need to be in your model need to be made by you, right? For standard hardware, for things that are kind of universal, things like nuts and bolts, it's usually better to just use a standard CAD. But sometimes after you do that, you might run into a need where you need to modify a part that someone else gives you, right? So there's a lot of instances where this might show up. For example, you might download something and the part that you're going to be using is basically the same as the one that you got, but it's just slightly different. Like maybe you need a bolt that's not a standard, like it's standard in everything except its length, right? Maybe they only sell bolts that are 1 inch long or 1.5 inches long, but you need one that's like 1.25 inches long. So you're gonna have to modify the CAD that you downloaded. Or maybe you're working on like a group project, someone else is in charge of a different system, you're in charge of another system, and then they send you their model and you need to change it so that they can integrate together. Or even you're just working with things that you yourself created in the past, right? If you've seen my Onshape like home page, I have tons of old documents from all the other classes that I taught, and after a few months, I don't even remember what's in them. So all of the times I might need to modify things that I myself created. So all CAD packages, all softwares will have some way for you to kind of interact with the history of the part, with the way that the part was created. So except in cases where you're just downloading a straight up model, like a step file or an STL file, if you're working in Onshape, for example, and you're working with somebody else's Onshape part, then you're almost always going to have access to their feature tree, right? So if I haven't used this term in this class before, this thing on the left here is what I like to call a feature tree. So it's just kind of a chronological list of everything that's happened in this part studio. To kind of go over what that means, when you first create a new part studio, there's nothing there, right? The only thing that's there is your origin and your top, front, and right planes. So that's kind of like the first thing that's in this list. It's even called the default geometry. And then it has every time you create something, you create a sketch, you create a 3D part like a extrusion or a revolve, it adds it to the list one by one. So you can tell in this part, for example, the first thing I did was make a sketch, then I extruded it, then I filleted it, I created another sketch, and so on. And I can go back and I can edit any of these entries, any of those entities. So that's kind of what that shows. And another useful thing that's there that you might not have used before or seen before is what's called the rollback bar. So it's a bit subtle here, but you'll notice that there's this little bar here on the left that you can click on. So take a moment, open up an old Onshape document that has multiple features in it, and just try dragging this roll bar backwards. And so you can kind of think of it as like you're traveling back in time, right? What just happened here? I rolled back my rollback bar and the part completely changed. But what happened is that everything that I did after the rollback bar is now suppressed, it's hidden, and everything before the rollback bar is still there. So it's kind of like I went back in time to before I did all of this stuff, but after I did this stuff. You can see as I move the rollback bar forward feature at a time, it starts populating like all these features that I have now. So play with it a bit. Hopefully it's pretty intuitive. And now you might be thinking, why is that useful? For one thing, if you're editing things, a lot of the time you want to keep your document well organized, right? I like to stress a lot that you want your models to make sense to other people who look at it. So sometimes that comes from things like we've talked about before, like construction geometry, where you want to make all your lines and stuff that aren't part of your boundaries. You want those to be construction lines. And it also comes at a higher level when you're working with your whole like part. If I'm going to do, for example, fillets, it's often a good idea to put all of your fillets at the end of the document, because if you do a fillet really early, there's a chance that that might end up getting like merged into or interfere with another feature that comes later on. These things will start to make more sense as you work with more complicated models, but for right now, you can, if you haven't run into it before, you can take my word that it often makes sense to put your features in a certain order. So when you do things and you create a model, you're often going to have a reason to go back and add more features. And if you're trying to add these features, a lot of the time it's easier to work with them at a time when you just created other kind of adjacent features that are related to it. So for example, if I needed to create like another boss here at the top, make a little knob. If I had to do that, then it would make more sense to do it now here rather than after I do all my fillets and stuff and make it round around this edge. Anyway, so hopefully we have more people here now. Maybe not. There's a link in the slides and I'll paste it again into the chat. I'd like you to open up this part in Onshape and create a copy that you can edit. So when you just click the link, I believe what happens is that you get a copy, but you can't edit it. And so there should be a button or an option somewhere up here that lets you edit or create a copy of the document to edit. So let me do that. Let me know if you have any problems, and also let me know once you have a copy of that part that you are able to edit. All right, are we all good with getting a part like this? All right, if so, okay, so here's the scenario. Let's say someone gives you this part, which is something, some part that you need in a system you're designing, but it's not quite exactly what you need. What you need is something that looks more like the image on the right, where the angle of the bends here is shallower. You can see here that this one is a lot steeper, this one is shallower, and there are kind of two bores in the ends here that are not present in the document that you are given. So I'll give you a few minutes. Your task is to edit this document to make it look like the one on the right. It's just I'll say that there's basically two things that you have to do. One of them is to put these holes here, and the other is to change the angle of these bends. If you have any questions about what I'm asking you to do, let me know. If you have any general questions, let me know. I'll come back in a few minutes and show you how to do it, or show you how I would do it. All right. All right, great. So if you managed to do it, can you tell us what you did to make these changes?
I added two sketches, one on each like handle part.
Yeah, so that's how you did the holes. you want to tell us how you change the angle of the bend here?
Wait, we were supposed to change the angle?
Yeah, so there are two things. One of them was putting the holes in, and the other one was making this angle shallower. Kind of, I can see in the difference here. If you didn't get it, don't worry. If anyone else has a comment about that matter. If not, seems like you got the second part pretty good. So yeah, it's not too complicated. If you get a part like this and you need to put some holes in it, usually pretty straightforward way to do that is just to sketch the holes and extrude them, or use the hole tool as we learned about. So as was suggested, you can just do something like that. And the same thing for this one here. You'll notice when I try to make these sketch circles, for example, Onshape kind of gives me a lot of help here. If I click on this highlighted box here that appears in the center, it'll automatically be located for me. You can see the center turns black as soon as I click it. And that just means all the necessary relations have been created to fully define that particular point. So that's the first part, or the second part, whichever. Those are the holes. And then the next part, to make this bend shallower, you're going to have to edit something that was already there. So the first kind of thing you have to do is figure out where in this feature tree is this particular feature created. And off the top of my head, I really have no idea looking at this, right? None of these features are labeled, they're not named properly, as will often be the case when you work with stuff. So what you can do is just roll back all your features one at a time until you figure out where it is that the particular feature of interest was created. So I just rolled back the two holes that I made. I roll back this fillet, I can see what that fillet was doing. I can see, oh, that extrusion was doing that. So that's kind of relevant, right? But this feature kind of has that angle built into it. But when I look into the sketch, let's see what I find. Basically what I see is that this sketch is kind of defined off what's already there. So the angle isn't built into this sketch. It's kind of built into something earlier than the sketch. So I have to keep going backwards. This extrusion, that's creating those two knobs, those bosses, these fillets, those are just rounding off these corners. So finally, I'm left with this sketch. And so I know, oh, to change this angle, I must have to edit this sketch one. So I go in, I edit it, and very conveniently, I see that there's a dimension here that has that angle that I want to change. If I just change that to a smaller number, like say 45 to 25 degrees, I can hit the check mark, and then I can roll everything forward again. I can see that the part edited, it updated, right? So this model was robust enough that you can change a dimension like that and it won't break. Be aware though that in a lot of cases, when you try to change something that's that far upstream, a lot of the time you're going to end up breaking things below it. It's going to have exclamation points, it's going to turn red, it's not going to be happy. And in that case, you're going to have to go through every single feature that's broken and fix it. But here we got lucky. So that's basically it. We went from the one on the left to the one on the right. So when you're giving a part, there's like basically two things you can do. Either model your own things on top of it, which is what the holes were. Like you're just adding your own things at the end of the part. Or you can go back and change the features that are already there, like we just saw with that angle. Hopefully that all made sense. Let me know if you have any questions. If not, we'll move on. And we're going to talk now about some of the handy tools that are built into Onshape that may be applicable if you are making things in real life, and also just in general are useful to have. So the first one is we're going to talk about is material assignment. So on the left here, below this whole feature tree thing, there's also a list of bodies or list of parts. And in most cases and things we've done, there's only been one part per part studio. It's possible to have multiple, kind of like we talked about before, where we had that like multi-piece shaft collar, or maybe if you have a ball bearing or anything like that, it's possible to have multiple parts in a part studio. But in our case, we're just usually going to have one. And then what you can do is you can edit the material. So Onshape, I guess, has a built-in library. I think you're also able to define custom materials here. But mostly what it's used for is for mass calculations. So when you're 3D printing, most commonly, it's probably going to be something like PLA or ABS for your standard like desktop 3D printers. You can see it automatically populates the density field based on its library. So let's say I'm going to make this out of PLA. That's how I would tell Onshape that my part is made out of PLA. You can also play with all the other ones which have different densities. And so this isn't the most useful thing in the world, but if you're trying to get an idea of how much your part will weigh, then you need to set the material to get an accurate estimate. So that leads itself to the second part, which is mass properties. If you look at the bottom right corner of your screen, you can see that there's two icons. One of them is a tape measure. The other one is a balance. So if you click on the balance, it'll display your mass properties. And so it asks you in this first field what part to measure. You can just click on the part. And so then you can see it fills in all these numbers, has these calculations. So for example, the mass of this would be 0.5 pound. Volume is 11 cubic inches, surface area, etc. These are some more maybe niche ones for what you might be doing. Center of mass, moments of inertia. Yeah, so those are more relevant if you're trying to do things like, I don't know, rotation or bending. If you're trying to analyze how resilient your part is, I guess, to either bending or maybe even just how this thing would sit if you were hanging it or letting it float. You can imagine that there may be scenarios where this is useful. But the most commonly used one is probably mass, where you're designing a system, maybe you want it to be lightweight, so you want to optimize your design to minimize the value that you get for mass, for example. Next tool I think we've talked about, it's the one right next to it, marked by a tape measure. And this one is the measure tool. So you can see measure tool is kind of smart, like the smart dimension is a smart tool. When you click on something, it'll basically tell you the important parameters related to it. So for a circle, you get the diameter, you get the center position, you get the circumference. For line segments, you'll get the length. And you can also select multiple things. If I click on this face and then this face, you can see it tells me like the normal distance between those two faces. So I basically it tells me that the thickness of this little flange here is 0.25 inches. If I click on two circles, again, it tells me the distance between these two circles in all three coordinates. For your reference, the coordinate system is on your navigation cube. So looking at it like from here, Z is up and down, X is left and right, Y is in and out of the page. There's your measure tool. I think we've used that one before when we're making our assemblies. But that one's very useful, especially if you don't have access to like your sketches. If you import a part and you don't know what they define a length to be, it's pretty handy sometimes to just measure off the part what different lengths are. Next thing is interference detection. If you ever create an assembly, you'll notice Onshape allows you to do a lot of things that aren't really physical, things that wouldn't work in real life. So let's see if I have an assembly. Let's use one of our old assemblies from the CAD 1 class, which is our, and this is when we learned how to use fasten mate. So we have these bricks, and in this example, it might be kind of obvious, like you might not see the full potential of why this is a useful tool, but let's say that I'm trying to mate these blocks together, and I accidentally do something like this, right? And I don't notice because I'm meeting hundreds and hundreds of blocks together, and I don't have enough time to pay attention to what I'm doing, and somehow this ends up in my final product. And this isn't really great because in real life, you can't have two objects that go through each other like this. So what you can do is use your interference detection tool. Again, this is an assembly level tool. And so it's here in this little drop-down menu under your navigation cube. You can see there's a interference detection tool. If you click on that, I think, yeah, it asks for instances to analyze. So maybe I have no idea where my interference is, but I suspect there might be one. I could just select all these parts. And as I select parts, you can see it starts highlighting stuff in red where solid material is occupying the same space as other solid material. So here you can see the intersection between my two parts that are going through each other. That's all indicated in red. And so when I see this now, it's pretty clear to me that I did something wrong, even if I didn't notice it before. So that's your interference detection. There's a few other tools that you can play around with that I didn't specifically include something for. Basically, in this drop-down view, you can just try clicking all of these, and they all do something that is to some extent useful. So perspective view makes it more realistic, maybe. Kind of, I'm not a huge fan of that. You can look at it different ways. You can see like your hidden edges. You can hide your edges, so none of those harsh lines. Look at wireframes, super messy wireframes where you can see every single line. This one is pretty interesting. It shows you how sharp your curvatures are. So it's not that useful here, but when you're working with more fluid flowing surfaces where it's hard to tell what the curvature exactly is, something like a body panel for a car, for example, you have a lot of subtle curves. This might be useful for distinguishing surfaces in that kind of setting. But yeah, so a lot of tools. If you have any questions up to now, let me know. If not, we will continue our work on our project. Okay. So just like last week, we'll finish off the class where I do another demo of a part. And then for homework, there's going to be one last thing for you to do. And then next week, we're going to start the assembly. So pretty exciting. Made a lot of parts, just need to make a few more. And we're going to start with the crank wheel today. Let me blow this up so you can see it better. All right, so first things first, let's look at this drawing. Take a moment to try to visualize it in 3D in your head. And then if you have some ideas, let me know in the chat or by speaking what you might start doing to model this. What kind of features you might use, what kind of shapes you see, things like that. All right. Looks like a bevel gear. Interesting comparison. So when you say it looks like a bevel gear, I guess when I think of a bevel gear, you kind of are associating it with like a 45-degree taper, right? I think most, yeah. So bevel gear is going to have this kind of like, I don't know if it has to be 45 degrees, but it's usually something like that to allow your gears to mesh at right angles. But it is kind of, I do see what you're getting at with like the 2-layered cake. So kind of have this boss here at the bottom, and then you have like another one here. So when you look at it from the side, that's kind of what you see. You see that little boss here at one end, then you have, I guess, what you're calling the gear here. Here. The main point being that both of these are circular cylinders. So you're not going to have any angles or anything. It's just simple, kind of like a 2-layered cake. So as I talked about, there's kind of going to be 2 ways you can approach this. You can either extrude 2 circles, or you can revolve one kind of L-shaped piece. Kind of illustrate what I mean. You can extrude your 2 circles, which hopefully you're aware of how to do. You also could do a different approach where you have your axis of revolution there, and then you have sort of a L-shaped piece. And you can imagine when you sweep this 360 degrees, what you're going to end up with is kind of a hole in the middle. Your first wheel, something like that. And then your big wheel on the outside. All right, no more of my drawing. Either approach is fine. Using the revolve will reduce the number of features you have, since you kind of get like a 3-for-1 deal. You get the hole through the center, you get the top cylinder, and you get the bottom cylinder all in one feature. That's a bonus. I guess it's easier to think about when you do it with extrusions. So it's up to you. Either approach is fine. Let's see. Oh, geez. Not mean to click that. I think I will personally, no, I might just do it with extrusions. So let's see. Yeah, I'll just do it the straightforward way. If you want to try the revolution method, I encourage it. But yeah, I'll just go through my little demo. You do your own thing. And at the end, we'll end up in the same place anyway. Right, so diameter of this big circle, can read off the drawing, it's 1.187. And just extrude that to a depth of 0.211. Then on top of that, I'll create another sketch. Make another circle. And the diameter of that one, I can see here is 1/2 inch. And again, I'll extrude that. And the depth of that one is going to be a little bit of math, but I can see that the total stack height is 0.461. And the one that I just created was 0.211. So the difference between those must be the extrusion I need to create. So 461 minus 211. So that's the main body of my crank wheel. It's my 2-layer cake. And now I just have to add 3 holes to finish it off. So there's that hole through the middle, kind of goes axially through the 2 wheels. Got one going kind of sideways. That one is for a set screw. And there's one more that goes through the flange, the brim of the hat, right here. So I'll just add those 3 holes one by one, starting with the one on the top. Just create another sketch on one of these planes. Doesn't matter too much which one. See the diameter of that hole, it's going to be 1/4 inch. So I'll just make my hole, missed there. And then I can simply extrude, remove through all. And there I have my first of 3 holes. I'll just run them in increasing order of I'll just do this one next. So we have one hole going through this surface. So I'll just create my sketch on that surface. Looking here, I can see with my line of symmetry here that it's going to be 0.5 inches radially away from the center. So what I can do, if I carefully position my mouse, you can see I get that vertical line relation that Onshape will automatically create for me. So I just carefully click right over the middle. So now you can see that it has that relation. I can't drag this left and right. To dimension the distance between the center of my wheel and the center of this hole, which is 0.5 inches, I can just get my dimension tool, click on the center of the first circle, click on the center of the other circle, and that's my dimension. And this is when I remember that I didn't need to make a circle, I just needed to make a point. So a circle will work. I'm just going to go back and turn that into a point. You can also just leave the circle, since the circle also is associated with a point, and you can use that point for the whole tool. But we are going to use the whole tool, so you don't need to have a circle. Yeah, so that's my feature. I just need a point that's 1/2 inch radially away from the center. In fact, it doesn't even need to be vertical. It just needs to be 1/2 inch away due to the symmetry of this whole situation. So there's my point there. And then, as you've hopefully used a couple times by now, we have our hole tool. And the way this works, we don't have a counterbore or a countersink, so we'll leave it on simple. It is threaded, so this is a new type of thread, the 6-32. So the size, the diameter of the hole is corresponding to a number 6 screw, and then the threads is 32 threads per inch. So every inch you got 32 threads, which is pretty fine. So I think last time we used 1032. The 6 is going to be, I believe, bigger. And it is threaded. The word thread implies that, you know, if the 32 didn't tip you off, the word thread hopefully tells you that it's a tapped hole. I guess maybe that's not obvious. A tap is a tool that you use when you're making things physically in like the shop. That you use to cut threads into a material. So they look something like this. They're basically a screw, except they have like these relief areas in them. If they were continuous, it would just basically be a really sharp screw that you use to screw into a piece of metal to cut out some threads. So basically the idea is you drill a small hole, a hole that's smaller than your actual screw diameter. Then you just screw one of these in, and these little sharp points will cut the threads out. And then you pull it back out, and then your piece of metal or whatever has the threads in, so that a screw or a bolt or whatever can go in easily. All we have to worry about though, this is a through hole. It goes all the way through, as you can see in the side view. And the location is going to be here. And that's all there is to that one. And last thing is that there is one more hole right here that goes through the side. So this one is the same type of hole. It's another 632, but it's in a different plane. So I don't really have a flat surface here that I can create a sketch on. So I'm going to take advantage of my right plane here. Just right here, create my sketch on that right plane. And for the location of this hole, I can see it's right on the line of symmetry here. So it's going to be centered with respect to the vertical direction. And for the horizontal distance, it's going to be 0.336 away from the end of the bottom here of the wheel. So from here to somewhere, it's going to be 336. Yeah, 336. So that's all there is to my sketch. I have that vertical relation there that was created automatically. And then I believe you can just use the hole tool. Well, let's find out. Yeah, so if you use the hole tool, I'm guessing it uses the sketch plane as the normal direction for where the hole should go, which is why we use the right plane. And you can see from the drawing, when you're looking at it head on this way, this hole is going to be on the right side rather than the left side. So I can change the direction with this arrow, but it's on the right side. Again, it's a 632 tab tool, and it's going through. And with that, that's the whole crank wheel. That's all there was to it. If you have any problems with this, let me know. If you have any questions about anything I did, if you want me to show something again, feel free to ask. I guess since we're recording, I guess for those of you who are curious, I can show you how you can do these three features all at once using the revolve. So depending on the context, this may or may not be a better or cleaner way to do it, but it does reduce the feature count. What's most important is going to be context, like what you're most likely going to change if you were to edit this feature. So yeah, it's really who's to say whether or not this is the better way to do it, but it is another working way to do it. I'll just start off with a line of symmetry there, my axis of rotation. And then I'll just go through and create this L shape that I drew earlier with my MS Paint skills. So here you do have to do a bit more thinking. You can imagine that these two lines are going to end up being what defines the diameter of your final part, right? So again, my diameters haven't changed. The outer circle has a diameter of 1.187. So that corresponds to twice of this distance, which is going to be 1.187 divided by 2. And now I have to go back and kind of rescale everything. The outer diameter of the smaller circle is 1/2 inch. So from here to here is going to be half of 1/2 inch or 1/4 inch. And then finally the diameter of the hole, which is the distance between these two, that's going to be half of 1/4 inch, which is 1/8 inch. There you go. And I can just put in my numbers. The thickness of this first circle is 211. From here to here, whoops. From here to here, 0.211. And the overall height was 461. And so that's my sketch. It's a bit more involved. Let me just hold that up for a few more seconds for the recording, whatever. Yeah. So yeah, this is an alternative way you could have done it. And now I can just revolve. And if I select this region and this axis, you can see that I end up with the same shape as I did before, but all is kind of collected into one feature, just this one revolve. So the same result as creating these three features, three extrusions. You can also do in a single revolve, but it's the same results. So just another tool that you have in your toolbox, and it's up to your discretion to use whichever one seems better at the moment. All right, so the last few minutes, I'll just tell you the assignment for this next week. So between this week and next week, I want you to attempt one or both of these two. So these are probably the more involved ones compared to the ones that we've done so far. This one is the upright. So again, this one's not the most complicated one. It's essentially a block with a lot of holes in it. The challenge comes from the fact that there's a lot of holes. So it's a pretty good exercise in terms of using the hole tool and reading a lot of dimensions. So if you think you need practice with that, probably do the upright first. But it's not too difficult technically. The other option, the other homework you can do is the flywheel. So this one you'd benefit a lot more from kind of thinking about how you would use a revolve to do it. It's also a bit harder to tell intuitively what the shape is just looking at the drawing, but it's also not too complicated. Don't overthink it. So this one's a bit more interesting in terms of like the technique, but they're both more involved than the ones that we've had before, but hopefully it'll be good practice to where you can get better at the whole making models from drawings thing. So yeah, I would suggest do one of them first, and then if you have time, try to do both of them. And next week, as I mentioned, we will be assembling the engine. So kind of starting to wrap up this project. Hopefully in the process, you've learned a bit about how to read drawings and gotten a lot more modeling practice. With that, if you have any final questions, I'll stick around. Feel free to ask, but that's all I have for you this week. So I'll see you again, same time, same place next week.